You may remember talking about the acetylide ion in Organic 1. So what you might remember doing is taking this triple bond with the CH, adding some strong base to that like NH2-, which takes that acidic proton. We get this acetylide ion, and then you can do a nucleophilic addition, maybe an SN2 reaction. And we called this an alkyne alkylation. So that was Organic 1. Now what we're going to do is apply the same chemistry to the reactions we've been talking about in Organic 2. So in this first one we have a ketone, and we know that the carbon that's part of the carbonyl is electrophilic. So that means a nucleophile can add to it. We've added hydride reagents, we've added carbon nucleophiles like Grignard reagents, but the acetylide ion is just another type of carbon nucleophile. So let's go ahead and break this apart, and we're going to say the sodium is sodium plus, the carbon is carbon minus. So we're treating this as just the acetylide ion nucleophile. I'll draw it down here. The lone pair and the negative charge. So the same way that this acted as a nucleophile to attack this carbon with the leaving group, it can do the same basic thing to an electrophilic carbonyl. So we can use the 2 electrons here on the nucleophile. Those will add to the electrophilic carbon, and these electrons are pushed up onto the oxygen as a new lone pair. So I'll go ahead and draw the intermediate structure right here. Here is O-. We've attached that triple bond, and in this case there's no leaving groups, so what we can do from here is just add the acid. We'll protonate the oxygen. Here's OH, and to make this look just a little nicer, I'm going to bring that triple bond up to the top. All right, on the second one, we're again using an acetylide ion. This one has an extra carbon attached, so we have a methyl group right here. But again, we can just treat this as this carbon nucleophile. But here we have the leaving group, so this acetylide ion will add twice. So the first time it will add, you'll lose the leaving group, and what you'll get is this, but you can't stop at that ketone, so it will continue to react. So we get 2 additions. So oftentimes this isn't that synthetically useful to add 2 alkynes, but it can be quite useful to be able to add 1 into your molecule using this type of chemistry.